In this episode of FUM0142 machining, we are machining dovetail. It's the female ducktail which is in the tailstock we have on the base plate. We have the male part of the ducktail, and when I machined that one, I decided that I will match the upper part with that dovetail. Well, now it is the time to face the music. Okay, measuring the dovetails here. These are the dovetails that I need to match this piece of iron into, and how to measure these? You could measure the bottom from here, the distance from here, and that would not give you an exact result. So the only measuring method that I know of that is accurate enough for this operation is using pins. I have these two pins. I call them coffin nails because they are really hard, and these two pins are exactly as I can measure with a micrometer, 8 millimeters in diameter. However, the diameter of these pins is irrelevant in this case, but it's useful to know. You will soon notice why. So there is a relation between when you are matching these dovetails, when you put one here and one there. So what you can do, you can take two measures from here. You can measure what is the distance of the outer sides of these pins. I already measured it, and it's in my case 129.14 millimeters. And there is no difference between if I measure it from the back side of here or the front side, so there is no difference. So these probably are also parallel, which is a really good thing, thinking about the future. Okay, so that's one measure. And the other measure you can take is the inside of these pins. And now, the relation between the matching dovetail when it's put here, in this case this is probably the male, and I'm going to mill a female. So the relation between those two is that when I put the pins into the female dovetail, so the measurement from the outside of the pins, when they are put inside the inside the female dovetail, is the same as the inside measurement from here. But since it's really difficult to measure the inside measurement, I measured the outside. But since I know that these pins are exactly 8 millimeters, so the inside inside measurement is exactly 16 millimeters less. That's it. Okay, those are the measurements that you need to take. That's one. And another measurement you really need to take, and that's as important when matching this, is the height of this dovetail. That one is, when you are matching those should be identical. And I measured this. I have this height or depth mic. I measured it from several places here, and the measurement I got is somewhere around 10.20 millimeters. That's actually the maximum I could get, and the minimum was 10.0, what was it? 10.19 or something like that. I could measure actually 300ths of a millimeter differences along these dovetails in the height. But I believe this is coming from the surface, because this surface is not exact. So with those measures I can already make the dovetails, but I also need to place them so that when I put it here, So the front side will be, well, it doesn't need to be exact match, but it shouldn't be it should be protruding just the slightest amount. So then it looks good. If it is the other way around, it looks bad. So therefore I will add 0.1 millimeters there, so it will be protruding this surface here. When I put the piece on here, it will be protruding probably 0.1 millimeters away from there. And for this one I need this bottom measurement, and well, that's not an easy measurement to take, and I got approximately 16 millimeters this side. Okay, so I make this side of the dovetail first, and then I make this one, and with this back side I will use to match that. Okay, that's how I do it, but this of course happens in the milling machine, not in the lathe. You cannot do this easily, at least in the lathe. And because this is now should be really precise, so I will tram my milling machine, and that's the next operation. Well, tramming the milling head. Well, that was actually, in this milling machine, this is an easy operation. First of all, this type of rotation, which is actually the tramming. So that was, I put the index on here, and it was right away spot on. So nothing much to do there. Well, yeah, there is 1/100th of a millimeter deviation from this position to this position. And I'm using the same parallel in both, because these are some Chinese stuff, so better to use the same parallel, because well, they probably are very well made, but well, yeah. So anyway, this one looks like it's okay. And then the nodding, which is this direction, this one, the index was, when I used the index here, indexing system, it made me 3/100th of a millimeter difference between. So I disconnected the index, and then used hammer to knock it into place, and now it's exactly what it should be. Well, and well, the system of tramming, it's you could use the system with dual dial indicators. Well, maybe it's beneficial, maybe not, I don't know. I can manage with one. And in this case, you can make all these things yourself. This is not rocket science making such a thing. Just the funny part here is that the device itself doesn't need any precision. So just that it fits into there, and you can tighten it there in your collet. And there is oil. And by the way, this paper here is because I oiled this, and now it's dripping a little bit, so I have a oil collector. So yeah, so no precision required, just that you can attach it, and then you can attach a dial indicator there like this, and there you are. Well, this is so, I should say, self-aligning system. So there you are. And now it's trammed, and next thing to do is to set up the workpiece into the table, and that's a little bit more involved, so to say. Well, this here is my way to do this setup, and well, I found out something about this milling machine. It's well, it's quite precise actually. So let me show you. So this is just a parallel, and it's I have taken away any dings here in the back, and everything should be really clean here. So yeah, and now when I put this against that pull it a little bit like that from the back side and then move it so that I can measure it. It's there. Okay. Now the needle was moving, and when I test how well did it align itself, it's inside 1/100th of a millimeter this way. Yeah, the needle moves, but not a lot. So let's see if I push it a little bit harder, if I can get it even better. Yes, I can get it even better. So actually I can rely on that kind of setup, because now when I'm milling the top surface here, I need to move the holders, and the critical thing here is to get it perpendicular. That's one, and then I should be able to put it back there in a precise way so that it's precise in the Y direction. The X direction isn't critical because well, it's used to move the table and mill the things, so that's not critical. Y is critical, and of course Z, but that's easy enough. Just clean up everything so it goes back where it was. So I think I can manage with this one only. So I don't need to do anything more than that. I could put some fences around here and align it really perfectly, but well, those should be on my way when I'm moving the holders around here. So for this reason I'm going to use this thing. And now the next thing will be to put it and start. The first thing I'm going to do is to resurface this because there is one spot which there is no height deviation, but the surface finish is bad. In a way bad. It's not as good as everywhere else, and furthermore I want to mill it this way because the movement on the dovetail is this way. So that's the next. Okay, now this horror show here is to find the edge of this cutter, align it with the edge of the piece. And yeah, I have clamped a parallel here so that when this one gets grabbed by the tool, it will be 0.1 millimeter away from the edge. So let's see, just try not to cut the parallel. There it is. Yeah. Okay. Let's lock it. Stop it. Oh yeah. Okay. So now I can. Yeah. So now this edge of this cutter is away from this edge 0.1 millimeters. Okay. Yeah, and then I need to take care of the backslash. And I said 16.5. Okay. 16.5. That would be 16.5. Okay, next step. Let's put the height correct now. Well, I can rotate this one. Okay, let's put it somewhere there in the middle and start doing this. There you are. And furthermore, I need coolant here, because not so much, because I would like to cool down this. It doesn't heat up, but I need to flush the chips. Okay, and therefore I need the coolant, and I will set it up next. So I have done now this slot here. It is at the moment 9 millimeters deep, quite exactly actually. And the target here is 10.2 millimeters. But I will now mill it to 10.1 and leave the 1/10 of a millimeter for finish, because the surface finish is typical roughing. Roughing end will finish, and therefore I would like to also, even though this is not a functional surface, I would like it to have a decent finish, and this one is semi-decent. So now I will cut the last one for this one, and after that I will be stepping over up to the bitter end. Okay, now this roughing is done, and I have 1/10 of a millimeter to go more from this one. And after that, well, I hope I get a little bit better surface finish. This is not exactly bad, but it's really rough. So that's one. And after I have done this surface, then I will start milling the actual dovetails. Okay, here is the real music starting. What I'm doing here is try to adjust the level of this Z-axis. It just barely cracks, and this one is now 0.1 millimeter away from the surface. Next step is to touch yeah, there you are. So, when we do this dovetail, the first dovetail, this is just by eye actually. I make it so that it's fully formed, and that's it. There it is. Well, this is now the moment of truth. Not yet, but pretty soon. So I have set up this block the other way around. The dovetail here in the back is already done. I debored it. And what I'm going to do here is to match this dovetail to the dovetail in the lathe. Well, and how this happens is that I will put one pin into here and another pin here when the dovetail is there, and then I will measure the outside diameter, and that should be the same as the diameter measured inside the pins in the lathe. So at the moment I know what it should be. It should be 113.14 millimeters, and this should be quite exact. And there is a reason why it should be exact. Well, of course it should be exact, but really exact, because I will make here some tightening screws which will then squeeze this one into the dovetail there. And there will be no gips, it will be machined quite exactly to the correct dimension. And now I need to test it somehow, so I have designed the setup. So I must remove this one while testing it, and because actually this pin method, these pins will give you quite near, but I doubt I must finalize it just by testing. Overshooting this one is a real risk here, and yeah, and it must be deburred before I try it out, because, and yes, the burr it produces here is horrific. So let's see how this goes. So now I will just mill it, and this takes some time. So I have already filmed this dovetail. This is quite the same. The measuring is different in this side, but yeah, okay. So let's mill. So here is now the matched dovetail. It's well, quite precise. There is a little bit of wiggle, yeah. And furthermore, this is a feeler gauge of well, 500ths of a millimeter, and you can put it there, so that what this means is that you can fish it all around and it goes all the way. That means that it doesn't touch this surface, it's touching that and that surface, which is exactly what I intended. So what's next with this one? Well, a braking system. At this end I will split this with a slitting saw, do some so that there is a flexure, and then I will put 3 M6 bolts here, which I can tighten the gip. It's like a gip, but it will not be a gip, it will be a brake, so that you can fix it on a place here. This will be in the next episode of Grip Machining. Till then, bye!